In this video we're going to talk about splitting the middle. Splitting the middle is a method of factoring polynomials, specifically polynomials with three terms. There's a good chance that you're going to spend a lot of time talking about splitting the middle in your class, but this video will kind of supplement that, or maybe the other order depending on what order you watch them in. Splitting the middle is a really powerful, really useful way of factoring polynomials. It makes it really easy. But first, I just want to review again what it looks like when you multiply two binomials together. If we have something like 10x minus 3 times x plus 5, for example, we would do the double distribution, 10x times x plus 5 minus 3 times x plus 5. And that gives us 10x squared plus 50x minus 3x minus 15. Combining like terms ends at 10x squared plus 47x minus 15. With splitting the middle, we would take this polynomial here, the 10x squared plus 47x minus 15, and work backwards through the process to get back to the two binomials that we multiplied together to get it. And it's literally going to be step by step by step, because what we actually do is split the middle term. We take that 47x and split it into two different terms, like, for example, 50x and negative 3x, and in doing so, we have something that we can factor by grouping, which you might have already learned about in a different video. So splitting the middle is just a way of creating four terms from a three-term polynomial. So if we were starting here at 10x squared plus 47x minus 15, we would need to figure out a way to split the middle term into two terms that we could then use to factor by grouping. The issue, of course, we know what it is, we know what it should be because we've already multiplied it out. But the issue is, as things stand right here, we don't really know how to do that. We don't really know what two terms to split the middle term into. So the way it works is this. We're going to create a factor x. Your teacher might call this something different, and there's a good chance you've done a bunch of these as a warm-up already. But what we essentially want to do is exactly this. I want to find two numbers that add to 47, since after all that's where those things are coming from, that add to 47 and multiply to the front and last numbers, the leading coefficient and the constant. They multiply to the same product as those two numbers. So we take the product of the first and last, so product of first and third terms, and then the sum, of the middle, so the middle term. We want two numbers that multiply to negative 150 and add to 47. Now, they multiply to negative 150, that means one of them is going to have to be negative. And if I want two numbers that multiply to negative 150 and add to 47, you could list out the numbers that multiply to 150, 1 and 150, for example, 2 and 75, 3 and 50. In fact, there we go. If we have 3 and 50, or more specifically, negative 3 and 50, then those are the two numbers, because they multiply to negative 150 and add to 47. The really neat thing about splitting the middle is it doesn't matter what order we write those terms in. Here we had 50x minus 3x, and you can see how we would factor this by grouping. We'd take the 10x squared plus 50x, pull the 10x out, have an x plus 5 left. We have the negative 3x minus 15, pull the negative 3 out, and be left with an x plus 5. The x plus 5 in common there means we have the 10x minus 3 in one binomial, and the x plus 5 as another. I'm going to do this in the other way around. I'll have negative 3x here and 50x here, and we'll see what happens. I look at the first two terms, 10x squared minus 3x. The only thing those two terms have in common is x, and so I pull that out. 10x minus 3, or plus negative 3. Then I look at the second two terms, 50x minus 15. The only thing that those two terms have in common is a 5. So plus 5. 50x divided by 5 is 10x. Negative 15 divided by 5 is negative 3. And so there we go. 10x minus 3, 10x minus 3. Those come together as one polynomial. And then the x plus 5 is the other. Remember, multiplication is commutative. It doesn't actually matter what order you write them in. If you write it like this, x plus 5 times 10x minus 3 versus 10x minus 3 times x plus 5, you get the same result. It doesn't matter which order you do. So this then is the way that we would factor by splitting the middle. We find two numbers that add to the middle term and multiply to the same thing as that product. We split the middle term into those two numbers and then use factoring by grouping. That's how splitting the middle works. We'll do another example. Let's see. Negative 30, x to the 4, y to the 3, minus 125, x to the 3, y to the 3, minus 120, x to the 2, y to the 3. This looks ridiculous, but it's not so bad. Because remember, before we do splitting the middle, before we do factoring by grouping, before we try to look for a difference of squares, before we do any other type of factoring, the first kind of factoring that you should look for is the greatest common factor. Look at all of the terms together and see, is there anything that I can take out of all three of those terms? Definitely include a negative if you can. In fact, it's worth noting, even if these two terms were not negative and the leading term is, in the long run, it makes your life a lot easier to take out that negative. If the leading term is negative, take out a negative as a GCF. And those two things will change to negative signs. Trust me, it'll make things a lot easier to deal with. But those are actually negative. Now looking at these, you might think, well, maybe 30, because 30 goes into both of those, but 30 doesn't work there. Turns out that only 5, negative 5, is part of the GCF. We can take out at most an x squared, and it looks like they all have a y to the 3 in common. And so that's our GCF. And what we have left then is 6x squared plus 25x, because remember we're taking out a negative, so that does become positive now, plus 24. That's the GCF. That's done now. It doesn't have any effect on the polynomial anymore. We look at what's left in here and see, is this something we can factor? We can't factor it by grouping, not yet. There's only 3 terms. Remember, factoring by grouping we can only use when we have 4 or more. But what we want to do is create 4 terms. I want to take that middle term and split it into 2. 6x squared plus something plus 24. And with the negative 5x squared y to the 3rd out in front. As before, I want to find 2 numbers that add to 25 and multiply to the same thing as 6 times 24. And 6 times 24 is 144. I want 2 numbers that multiply to 144 and add to 25. Pause the video for a second, see if you can figure it out. Maybe you identified it right away, but if not, pause and see if you can figure it out. You should have it. It's 9 and 16. And again, it doesn't matter if you do 9 and 16 or 16 and 9. We have 9x. Three. 16x and 24, a little bit more tricky. I could take a 4 out, but it looks like, because remember, I'm hoping to get this, the 2x plus 3, and 8. I can take an 8 out of both of those things. And I'm left with the 2x plus 3. And so that gives me now 3x plus 8 times 2x plus 3 with the negative 5x to the 2, y to the 3 out in front. Take the GCF out first, get rid of the greatest common factor, and then whatever's left, use either the splitting the middle method or factor by grouping or difference of squares, any of these factoring methods, to find that thing down there.